Hello Internet. Today we have this 4090 from MSI that came in for repair with a huge dent on its back. Maybe shipping and handling? I don't know. There's also a sign of abuse at the PCI Express slot, but those are not critical. Let's take this thing apart and see what's inside. This MSI Ventus is built rather well. No DR mosses left behind, except for those that are on the left are cooled by the bracket rather than the heatsink. I don't know why they did it this way. I think it would make more sense to do it the same as on the right, but I don't know. I just work here. Perhaps the lack of 10 phases is the reason for such insufficient cooling. But having less phases creates more heat, so it should be the opposite. Or maybe MSI didn't think very hard when they converted Supreme into Gaming Trio or Ventus version PCB. I don't know. We do, however, have pads on the back that will help to aid this problem to some degree, so yay, I guess. Anyway, the backplate can be easily made as flat as the earth just by making it flat again, like so. But I doubt it's going to give us any FPS boost, so that was a waste of time. Using an ohm finder, no bad ohms were found, and using a volt finder, I found about 25 volts total, give it or take. And since everything is looking great, let's see if we can get a picture from this 4090. No picture, and according to Linux, no detect either. Since we have no detect, let's check for all power stages and make sure that they are all working correctly. Sometimes one failed power stage will prevent the card from displaying an image, but in this case, everything seems to be okay. Next place to look would be an activity on the BIOS chip. With an oscilloscope set to the roll mode, we're looking for pulses on the data pins. Nothing on this pin, and a high signal on this pin. Not good. Let's check for the oscillator and see if it generates a frequency at which GPU is talking to the motherboard. And there's nothing. That means we need to lift the core and see what's going on. There we have it. Lifting the core revealed a ton of ripped pads, and this 4090 is going to be a no fix. Some of you would scream at me demanding a fix, but what you may not understand is, fixing that many ripped pads is not good practice. It may work for a week or two, but it will eventually break, and the card will keep coming back for warranty repair over and over, making each core lift cause more damage and even more repair. And with that there, we have a no fix for this 4090. So customer sent me this donor PCB in hopes that I can transfer all of the working components over and hopefully resurrect the dead. The only problem is that whoever removed the core and the memory from this board did not care about the board at all. Board is extremely overheated to a point of almost all of the electrolytic capacitors were bulged and needed to be replaced. There are missing components in several places, which means I have to restore this board to be fully functional before I'm able to do a transplant surgery. Before I start, I have to remove all of these shorted solder pads from the board and get it cleaned up and ready to go. So here we go. Some visual inspection later, I found damage traces, but no ripped pads, which is promising. And before I start transfer, as I said, I have to test this board to make sure it is not dead. I'll be using this cheap Chinese death finder, and I found a short on memory. It turns out it was a solder blob left by the guy who removed the core, shorting this capacitor. Easy fix, and the short is gone. Now let's power it on and see if it blows up. We have 5 volt, 1.2, but no 1.8. 1.8 volt comes from this buck converter, so let's look at the enable signal, and we have 0 volt, which means this buck converter is not turned on. Enable comes from a series of resistors that we do not have on this board, so it must have come from somewhere else, most likely this resistor on the back or this one at the front. So let's check at the front first. And there we have it. The resistor is missing, so let's take it from the original card along with some other resistors while we're at it and put it all there and see if that helps. Do we have enable now? Yes. And we have 1.8 volt. And we have the core, and memory, and PEX. Perfect. Now I'm ready to transfer the rest of the missing components. Okay, transfer is complete. All readings look normal, so let's plug this thing into a PC and hopefully we get a picture. We have a picture, ladies and gentlemen. I'll run into Windows real quick and see if all the sensors are working correctly, and it looks like it does. So, next step would be to put it all together, run stress tests, benchmarks, you know, the usual, and we have a winner. Let me know what you guys think about this repair in the comment section below, and I'll see you later. Goodbye.